This is Advanced Math 9.1 Basic Combinatorics, which are talking about combinations and permutations. So the first question we want to think through is how many different ways can three objects be arranged? How many different ways can three objects be arranged? So for this example, let's just use A, B, and C. We're given A, B, and C. We want to figure out how to arrange these three things. We already arranged it one way, A, B, and then C. But I want to kind of give a visual on how we can figure this out. So we have A, B, and then C. And so after A, I could choose B, and after B, I could choose C. But I also, after A, could choose C and then choose B. So already we have two different ways that we can arrange this. So one way is ABC, one way is ACB. If I start with B, I could choose C and then A, or I can choose A and then C. And so this is two more ways that we are being able to arrange these three objects. Lastly, choosing C first, I can either go with B and then A, or A and then B. And so in the end, we've taken three objects, started with three things, and we wanted to arrange it in three different ways. Okay, and so this is what we're taking a look at today, arranging objects in different arrangements. So for this first example, the Tennessee license plate consists of three letters of the alphabet followed by three numerical digits, 0 through 9. Find the numbers of different license plates that could be formed from the following. So first A, if there is no restriction on the letters or digits that can be used. And so this is where we start to ask ourselves, okay, so I have 6 spots that I'm filling up on this license plate. Again, they said it was 3 letters followed by 3 numbers. And so I'm just going to write a little ABC, 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 and here is 1, 2, 3, 1, 2, 3, and 1, 2, 3. Essentially alphabetical and then numerical. So the question I'm asking, if there's no restriction, that means it could be AAA 111. That's one of my options. So the question is, how many options do I have for this first placement? The first thing that I'm placing on this license plate could be A, B, C, and so on. I have 26 different options. For the second one, since I could have A again, I again have 26 options, and for the third, the same. Be careful on this one, since it is 0 through 9. That is, as I said earlier, it's 10 digits. So I have 10 options. 1 through 9 and 0 is included as well. And so I have 10 options on each of these. So what we're going to do is we're going to take each of these numbers times the other to find out how many different ways, or how many different license plates essentially can be formed if we do it. And if we were to multiply all of this together, we would get 17,576,000. So there's 17 million different ways to arrange three letters followed by 3 numbers. Next, we're still working with the same concept here. We're saying that it's still a Tennessee license plate, so that's 3 letters followed by 3 numbers. However, it says no letter or digit can be repeated. And so now I have to think, okay, this very first letter here, again, it's A, B, C. The very first letter can be any of the 26. However, for my second scenario, the second space that I'm filling, I only now have 25 options. Again, that's because whatever option, I don't know which option it was, whatever option I used in the first place can't be used in the second. the same thing goes for the last one. I now only have 24 options because let's say I used A, then I used B. How many letters are left in the alphabet? 24. For the digits, I have 10 options. I use one of them. I don't know which one. I'm down to 9. I'm then down to 8. So we're going to multiply all of these numbers together in order to get the number of ways that we can arrange a license plate if we have no repeated letters and no repeated digits. So if we multiply all this together, we would get 11,232,000. Again, it's definitely less because we took away some of those options. Still quite a few license plates that you can go through if you don't want to have ones that read AAA 111. Now we want to talk about distinguishable permutations. So the difference between a permutation and a combination is the permutation, the order in which I select something matters. Combination, it doesn't. And so actually, I'm going to skip down to example 3 first. So distinguishing combinations from permutations. In each of the following scenarios, tell whether permutations, ordered, or combinations, unordered, are being described, then find the number of ways it can be done. So, a president, vice president, and secretary are chosen from a 25-member club. And so we are choosing 3 different positions: president, vice president, and secretary. So does the order in which I select them matter, or does it affect the outcome? I'm going to go ahead and tell you that yes, it will affect the outcome. So I'm choosing from the 25 members. We can use let's say it's just the alphabet. Everyone has a name that starts with a different letter of the alphabet except Z. No one has Z. And if I choose the person that's first name starts with A for president, and B for VP, and C for secretary, if I chose them in this order, A, B, and then C, well, the person with A is the president, B is vice president, and C is the secretary. What if the order in which I chose the exact same 3 things changes? C, A, B. Did it affect the outcome? Well, yes, because now someone else is president, someone else is vice president, and someone else is the secretary. So this is what we would call a permutation. And so we, in order to figure this out, we can actually use our calculators. You will say 25. This is the number out of the number being chosen. So there were 25 people in all. I choose P. I'm saying P because it's permutation. And so you'll see this on your calculator under the math category, and then it's NPC. Or for combination, it's NPR actually, sorry, NPR, and then NCR on the math function on your calculator. And so you'll type in 25P after hitting that button, and then you could type in a 3. So 25 people, we're choosing 3 of them, and we want to know how many different ways can it be done. And the number might surprise you because there are so many different ways that you can choose. It's only 25 people, but there's actually 13,800 different ways that we can choose who's going to be the secretary, vice president, and president. Again, we want to determine on B if it is a permutation or a combination. So does the order in which I choose them matter? And so again, let's say I'm choosing 5 potatoes from a bag of 12 to make a potato salad. Now, if I choose A, B, C, D, and then E out of the bag, let's say I carved letters into it first, took my time there, into each potato. I add these things into a potato salad, and in the end, which potatoes ended up in the salad? A, B, C, D, and E. If I change the order in which I choose, B, C, E, D, A, I picked these ones out, it's still the same 5 potatoes. Would it affect the outcome if I chose them in a different order when I'm still choosing the same 5 potatoes. And no, they're all going to the same place. They aren't going to change the outcome. The potato salad still has these 5 potatoes in it. And so this is where we find that it is a combination. And so in this case, we're going to enter 12 first because that's the total number of potatoes I'm choosing from. And then 5 is the number that I am choosing. And so if I were to plug this in, I'm going to find that there are only 792 different ways that I can choose these 5 potatoes. Next, a teacher makes a seating chart for 22 students in a classroom with 30 desks. You guys definitely know what this one is, if it's permutation or combination, because does the order in which the teacher choose matter? Obviously, yes, because if you're not sitting next to your best friend, then the order mattered. If I chose A, B, and then C, or A, C, and then B, the order has completely changed and it changes all the dynamics of the classroom. And so the order has mattered in which the teacher selects what student goes where. And so when we're figuring this one out, again, it's permutation. There are 30 options and I'm filling 22 of the seats with students. And so how many different ways can that one be? And this one, we're going to leave in scientific notation. It's 6.57 times 10 to the 27th. Again, that means that I could write this with moving the decimal place 27 times. So it'd be 6.57 with 25 zeros after it. So there's quite a few different ways that teachers can arrange their seating charts when they only have 30 desks. So let that be a warning. All right, let's go back to this one now. Speaking specifically of permutations, we want to count the number of different words, we're not going to worry if they're in the dictionary or not, that can be formed using the letters in each word. So for A, I'm given the word dragonfly. What we're going to want to pay attention to is if there are any repeated letters. And so in dragonfly, there isn't. And so this is actually another way that we can use permutations or use your calculator. So we have dragonfly. I could start rearranging the letters. So I could say, okay, well, instead of dragonfly, I'm going to say dragon. All right, I switched 2 letters. I switched the Y and the L. Yes, it's not a word, but this is a new arrangement. There's quite a few of them, a lot more than I am going to take the time to write down. And so this is one option. This is a second option. How many more are there? And so what we can do now is what we're actually doing is we're taking 9 letters, because 1, 2, 3, 4, 5, 6, 7, 8, 9 letters in dragonfly. And how many are we picking, or how many are we arranging? We're actually taking 9 letters from a set of 9 letters, and we're arranging all 9 of them. And so this is 9p9, or on your calculator, it's the same as 9 factorial. That's what that exclamation point means. 9 factorial. And so 9 factorial is actually just 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, all the way down to 1. Enter that into your calculator, and it's actually in the same place under math. And we will get 362,880 different possibilities. And so on these examples, we're actually going to be working with factorial a little bit. So dragonfly, 9 letters, choosing 9 different spots, and this is what I got. All right, I'll be right back with B in the next video.